Okay, so now we turn to exercises, and first we look at the first part on technology. So exercise number 1. How would you represent in the production function specification the fact that A. The technology does not allow for the substitution between the factors of production. So here we see that we cannot substitute the factors of production one for another, x1, x2. So in this case, it means that we have complementary inputs, and therefore this is going to be kind of complementary technology. So that's Leontief technology, and the formula is, so we write that production function, which is the function of inputs x1 and x2, is, and we just write some general form of Leontief technology. Okay, then we have B, and the substitution possibilities between the factors of production are independent from the level of the factors used. So essentially here what it says is that it does not matter how many units of x1 and x2 are used in the production. It's perfectly possible to substitute one for another. So here we have substitutes technology, and essentially the general form is going to be this one. Then we have C. An employee, input 1, working on a computer without operating system, input 2, is not productive at all. So here we could express it in terms of Leontief technology, because you need to use workers and operating system in some proportion, or we can also say that it could be also Cobb-Douglas technology. And just to show you with the example of Cobb-Douglas, so that's the general form of the Cobb-Douglas technology. And in this case, if we have that, let's say x1 is number of workers working, and x2, that's the number of operating systems, and let's say that now we have worker but without operating system, so x2 is 0, it's going to be that 0 to the power of b equals to 0. And so in this case we would have that basically that production function would give us 0. But it could also be possibly, it can be also possibly correct as another solution to write it in terms of Leontief technology, because here we have mean function, and so if x2 is 0 or x1 is 0, in this case we would also have 0. Okay, so that's also another possibility. Then we have D, and so here an employee, in order to cut down a tree you need one 2-man crosscut saw, input 1, and 2 lumberjacks, input 2. So we need one instrument, one saw, and 2 people to cut the tree. So I will also show, you will see the separate video, how to translate the condition, like the sentence, into the functional form, basically, where you have to show a complementary goods function with mean. So how do you do it when you have some question, basically description? And so, as I said before, you just need to remember that coefficients, so coefficients here in front of x1 and x2, so first we write mean and then a and b, okay, these are going to be just the opposite of what you have in reality. So in reality we have one crosscut saw, okay, which is x1, and we have 2 people, which is x2, which means that so it will be just the opposite here in function of the real proportion. Okay, so we have two people, so actually we have two people and we have one saw, but here when we write our coefficients, it should be just the opposite. Okay, and also it perfectly makes sense, so when you substitute 2 here, substitute 2 here and 1 here, actually the output of the function is going to be 2, right? Because you see 2 times 1 is 2 and 2 times 1, 2 here, and so we have that output is 2. Okay, and then the last one we have the question E. Okay, so we have function E. The technology exhibits increasing returns to scale, and here we're just going to show that it's some general function that exhibits. So we just need to write generally how do we express the increasing returns to scale. Okay, so here it just says that if we increase all the inputs by some factor t, then output will increase more than if we had just taken our output, okay, and just multiplied it by t. Alright, so that's just kind of the general form how we can express that function has increasing returns to scale.